This is the second half of your review. Remember, you're going to have solving linear and nonlinear equations. You're going to have where you're solving using back substitution. You'll have a couple that are in this form where you're given 3 equations with 3 variables, and you have to work it out so it's in a triangular system, meaning you have z equals, z and y equals, then the top one says x, y, z equals, and then solve it. And then we'll have some partial fraction decomposition stuff. So let's go through this first. The first thing you need to do is say, okay, are all of my variables lined up? Are all of my x's on top of x's, y's on top of y's, z's on top of z's, and then we have our constants. Yes, we're good. Now, you need your first equation to be a positive 1x. Is it? Right now, as it looks, that's a 4x, right? Is there an equation that you could manipulate somehow to where the first coefficient would be a positive 1 on the x? The bottom one, right? You'd have to just multiply or divide everything by -1 to change that, correct? So I would rewrite this as x minus y plus z equals 4. And then you can write the other two underneath it. It doesn't matter how you write them. You can write the 4x plus 2y plus 3z equals 8. And then the 2x minus y minus z equals 18. Or you could have written the 2x1 and then the 4x1. It doesn't matter. So now that we have our equation set up that we're ready to start, we can go ahead with that. All right, so I'm going to go over here. I'm going to create my first equation. We're going to have a little bracket brace thing, and I'm going to write the x minus y plus z equals 4. So now my second equation should have just a y and a z. So we're going to take 1 and 2, and we're going to eliminate x's. So x minus y plus z equals 4. 4x plus 2y plus 3z equals 8. So what would I have to multiply that top equation by so that my x's would cancel out? -4, good. -4 all the way through. So this becomes -4x, negative and negative is positive 4y, negative times 1 is -4z equals -4 is -16. So when we combine, our x's cancel out. 4 plus 2 gives me 6y. 3 and a -4 gives me -1z equals 8 minus 16 is -8. So there's my second equation. 6y minus z equals -16. So my last equation, I wanted to say just z equals. So we're going to have to do a 2-step process. We're going to have to take the first and the third and eliminate x's. So let's do that. X minus y plus z equals 4. And 2x minus y minus z equals 18. What would I have to multiply the top equation by so that my x's cancel out? -2. So I have -2x plus 2y minus 2z equals -8. So my x's cancel. I am left with y minus 3z equals 10. Agreed? All right, what did we say we want our last equation to say? Z equals. Does either equation have just z equals in it? No, that means we have to take these two and eliminate our y's. Does not matter which one you write on top. I'm just going to say y minus 3z equals 10. 6y minus z equals -8. What would I have to multiply the top by so that my y's will cancel out? -6, okay. So -6y plus 18z equals -60. My y's cancel out, which is what we wanted. -1 and 18 is 17z equals -68. Divide both sides by 17. And I come out with z equals, what's -68 divided by 17? What kind of 4? -4. So I left up here with z equals negative 4. Now, in order to answer this question, you should have an ordered triple. You should have an x value, a y value, and a z value. Do we have that yet? No. But we have all the information to work backwards and find that. So I can find my x, I can find my y, and I already found my z. We said that z equals negative 4. So I'm going to take that z value, I'm going to plug it in right here. So 6y minus a negative 4 equals negative 16. 6y plus 4 equals negative 16. Minus 4 from both sides. 6y equals, what's a negative 16 and a negative 4? Negative 20. Yes, you are right. Look, guys, this was negative 8, remember? I recopied the wrong number. Thank you. I was like, wait a second. Okay, so this is negative 8, right? Yeah. Okay, so now when we plug in z, we have 6y minus a negative 4 equals negative 8. So 6y plus 4 equals negative 8. Yeah, it makes more sense now. Minus 4 from both sides. 6y equals negative 12. Divide both sides by 6, and y equals what? Negative 2. Good. So y is negative 2. And then to find x, we take the y and the z that we just discovered, and we're going to plug it in to find out what x equals. So x minus y is negative 2, so negative 2, plus a negative 4 equals 4. X plus 2 minus 4 equals 4. X minus 2 equals 4. Add 2 to both sides, and you get x equals 6. Right? Does that look like it probably is the correct answer? I would take 2 seconds, pick up your calculator, and just plug in. And I would say, okay, I'm going to hit 4 times. I found out x was 6, plus 2 times y is negative 2, plus 3 times negative 4. When I hit enter, I should get out 8, and I do. So now I'm going to do the exact same thing, and I'm going to say, okay, second equation. 2 times 6, which is our x value, minus y is negative 2. Negative 2. And then I have minus a negative 4. And when I hit enter, I should get 18, and I do. And then I'm going to check the last one. I have a negative x, which is negative 6, plus y is negative 2, minus z is negative 4. And when I hit enter, I should get out negative 4, and I do. So I just took 30 seconds to check that my order triple was correct. You guys with me, everybody? That makes sense? All right, let's do the next one. What's the rule? What do I look for? The first equation should be what? Positive 1x. Is it? Yeah, so we're good. Let's just go ahead and rewrite that first equation. So x minus 2y plus 3z equals 1. So now I'm going to take 1 and 2, and we're going to eliminate x's. So x minus 2y plus 3z equals 1, and 2x plus 4y minus 2z equals 26. And what am I multiplying this top equation by? So my x's will cancel out. Negative 2, good. We're going to go through all the way through. So negative 2x, negative and negative is positive 4y, minus 6z equals negative 2. So my x's cancel. 4 plus 4 is 8y. What's a negative 2 and a negative 6 going to give me? Negative 8z equals, what's 26 minus 2? 24. What do you guys notice about this equation? You could take out an 8. If you wanted to, you could. You could make this y minus z equals 3. If you don't see that, no problem. Just your numbers are going to be a little bigger, but it'll simplify in the end, but that's fine. So here, my second equation is 8y minus 8z equals 24. So now my last equation should say z equals. That means I have to take 1 and 3 and eliminate x's first. So x minus 2y plus 3z equals 1. And 3x, excuse me, plus 2y minus 5z, which should be a z, equals 3. So what am I going to multiply the top equation by so that my x's will cancel out? Negative 3, good. So I have negative 3x plus 6y minus 9z equals negative 3. My x's cancel. What's a 2 and a 6? 8, good. Going to give me 8y. 5 and 9 gives me negative what? 14z equals what? 0. Okay. So for a second you're like, wait, what? 0, huh? That's okay. I want my last equation just to say z equals. So we eliminated x's from both of them. Now I'm going to take these two leftovers and I'm going to eliminate the y's. Doesn't matter which one you write on top. Does not matter. So I'm going to start with the blue. 8y minus 8z equals 24. 8y minus 14z equals 0. In order for the y's to cancel out, what do I have to multiply one of these equations by? Negative 1. All right, so I'm just going to do the bottom. Watch, I'm just going to go through and change. This positive 8y becomes negative. My negative 14z becomes positive. My 0 stays 0. I can write a negative there. It doesn't matter. But my y's will cancel out. What's a negative 8 and a positive 14? 6z equals 24 minus 0 is 24. Divide both sides by 6, right? And z equals 4. So we come back, way back up here, and I get z equals 4. Not my answer yet, but it is set up for me to find my ordered triple. I already know what my z is. We found out it was 4. I have to find x, and I have to find y. So I'm going to take z, plug it into this equation. So 8y minus 8 times 4 equals 24. 8y minus 32 equals 24. What do I do to both sides? Add 32. So 8y equals 56. Now what? Divide both sides by 8. And y equals? Perfect, 7. Now I'm going to take my y value and my z value and plug it into my top equation. So x minus 2 times 7 plus 3 times 4 equals 1. X minus 14 plus 12 equals 1. X minus 2 equals 1, right? Add 2 to both sides. And x equals 3. So I got the ordered triple of 3, 7, 4. So take your calculator real quick. Plug it into that top equation. For x is 3 minus 2 times 7 is y plus 3 times 4 is 12. And when I hit enter, what should I get? 1? And we do. Good. So now go to the second equation. 2x. So 2 times 3 plus 4 times 7 minus 2 times 4. And when I hit enter, I should get 26, which I do. And then the last one, 3 times 3, because our x value is 3, plus 2 times y is 7. And then I have minus 5 times 4. When I hit enter, I should get 3. And I do. So our ordered triple is correct. Long, long, long process, I know, but nothing you guys can't handle. We've done a bunch. You guys are going to be good. All right, last thing I want to work on is our partial fraction decomposition. And then, ladies and gents, we are done. If it asks you to write down the partial fraction decomposition, but not to solve, right? This is the easy part. How many pieces is this fraction going to be broken down into? Yep, 3. What are my denominators going to be, Raul? X plus 1. X plus 1 what? squared and perfect. My numerators, A, B, C. That's it. All right, these next ones we're actually going to solve. These might take us a minute or two to do, but we're actually going to go through these together. All right, first thing you do is factor the denominator. It's already done for us. So I'm going to go ahead and take a second and say, all right, when I go to solve this, I'm going to use x equals positive 3, and I'm going to use x equals negative 1. You guys agree? So now if we break this up into our partial fraction decomposition and then get our equation set up, my first denominator, I'm going to write x minus 3. If you write x plus 1, that's fine. My second, I'm going to write x plus 1. This is my A, and this is my B. So now that you've separated them into two fractions, now you have to figure out what each fraction is missing, because you want to make an equivalent. You want to make an equation. So A has the x minus 3. It's missing the x plus 1. B has the x plus 1, it's missing the x minus 3. Now our equation on top is true. So you can write 2x minus 14 equals A times x plus 1 plus B times x minus 3. And we're going to evaluate this. We're going to solve using x equals 3 and using x equals negative 1. So over here on the left, I'm going to say 2 times 3 minus 14 equals A times 3 plus 1 plus B times 3 minus 3. So as we go to evaluate, what's 2 times 3? So 6 minus 14 gives me how much? Negative 8. Okay. And here I have 3 plus 1 is 4, so I have 4a. And then what happens to 3 minus 3? Cancels out. So I divide both sides by 4, and my a value is how much? Negative 2. Good. Same thing on the right-hand side. We're going to evaluate using negative 1. So 2 times negative 1 minus 14 equals a times negative 1 plus 1 plus b times negative 1 minus 3. So 2 times negative 1 gives me negative 2 minus 14 gives me a negative 16. Negative 1 and positive 1 cancel, so my a is gone. And then negative 1 and negative 3 is negative 4, so I'm left with negative 4b. And then how do I get b all by itself? Divide by negative 4. So b equals 4. Now we take those two values and we plug them back into our original. So instead of a, I'm going to write negative 2 over x minus 3 plus, instead of b, I'm going to write 4 over x plus 1. You could also write this, guys, as 4 over x plus 1 minus 2 over x minus 3. These are the same. Just as long as your signs are correct, like that 2 is negative. So if it's negative 2 plus, that's fine, or if it's something minus, that's fine. They're the same things. Questions? Everybody at home okay? All right, next problem. They want us to find the partial fraction decomposition. So the first thing we have to do is factor the denominator. When I factor the denominator, what times what? Gives me a negative 6 when I multiply, but a positive 1 when I add. X plus 3, x minus 2. Good. So I'm going to go ahead and I'm going to solve, and I'm going to say, okay, when I evaluate, I'm going to use x equals negative 3 and x equals 2. So let's get our partial fraction decomposition set up. One of my denominators is x plus 3. One of them is x minus 2. I have a and b. Now that we have this set up, we figure out what each fraction needs. A has the x plus 3. It's missing the x minus 2. B has the x minus 2. It's missing the x plus 3. And now we have an equation that we can solve. Negative 5x plus 9 equals a times x minus 2 plus b times x plus 3. I'm going to evaluate this 2 times, and I'm going to use x equals negative 3 and I'm going to use x equals 2. So let's do this. Negative 5 times negative 3 plus 9 equals a times negative 3 minus 2 plus b times negative 3 plus 3. So negative 5 and a negative 3 gives me positive 15 plus 9 gives me 24. I have negative 3 and a negative 2 gives me negative 5, so this is negative 5a. And then what happens with negative 3 and a positive 3? Cancels out. Divide both sides by negative 5. So the a value I'm going to use is negative 24 over 5. Fraction? That's all right. Going to evaluate the exact same equation, but now we're going to plug in positive 2. So negative 5 times 2 plus 9 equals a times 2 minus 2 plus b times 2 plus 3. So I have a negative 10 plus 9 gives me negative 1 equals 2 minus 2 is 0, so this is going to cancel. 2 plus 3 is 5, so this gives me 5b. Divide both sides by 5. And my b value is negative 1/5. So now we go back up to our original. So my a value of negative 24 over 5 goes with x plus 3. And my b value of negative 1/5 goes with x minus 2. Will you see the answer written that way, guys? Probably not. Take your denominators and put them downstairs. So this is the same as negative 24 over 5 times x plus 3 minus 1 over 5 times x minus 2. Notice the minus signs. Gotta have our minus signs in there. Question. Last one. This one's a little longer, and that's okay though. First thing we have to do is factor the denominator. So what's 3 times negative 4? Negative 12, right? So I'm looking for factors of negative 12 that multiply to give me negative 12, but add to give me 11. X plus 12 and x minus 1. All right. Since my a term is not 1, I'm going to divide each factor by that, and we'll get the GCF out. So here I have x plus 4, and here I have 3x minus 1. Agreed? So take one extra step, and I'm going to solve this using x equals negative 4, and I'm going to solve this using x equals positive 1/3. Yes, you have a fraction, but that's okay. Okay, so now let's break up. I have two pieces that I'm breaking this up into. One of my denominators is x plus 4. The other denominator is 3x minus 1. I have my a and my b. Now we need to make an equivalent expression on the right-hand side so our equation is balanced, so it equals. So if I'm missing, or I have the x plus 4, I should say in my a, I'm missing the 3x minus 1. So that's what we multiply a by. In the second fraction, b, I have 3x minus 1. I'm missing the x plus 4. Now we have an equation that is balanced that we can solve. X plus 5 equals a times 3x minus 1 plus b times x plus 4. Go back to the beginning. What two values did we say we were going to use? We're going to evaluate where x equals negative 4 and where x equals positive 1/3. So negative 4 plus 5 equals a times 3 times negative 4 minus 1 plus b times negative 4 plus 4. Negative 4 plus 5 is just 1. 3 times negative 4 is negative 12 minus 1 gives me negative 13a. And then what happens with a negative 4 and a positive 4? Cancels out. So divide both sides by negative 13, and you have a equals negative 1/13. Same thing on the right-hand side. I'm going to evaluate using 1/3. So I have 1/3 plus. What's another way I can write 5/1 as thirds? 5/1. I want to change it to thirds. 15 over. Okay, so 15/3. Just for easier working here. Then I have a times 3 times 1/3 minus 1 plus b times 1/3 plus. What's another way I can write 4/1 as thirds? 12/3? Okay, agreed. Good job. So on the left-hand side here, I have 16/3 equals. These 3's will cancel out. 1 minus 1 is 0, so a goes away. If I have 1/3 and I'm adding 12 thirds to it, how many thirds do I have? How many? 13 thirds times b, right? So I'm going to divide both sides by what? 13/3 divided by 13/3. So b equals, guys, keep, change, and then what? Flip. So this becomes 3/13. Whoops. Don't know why I wrote 11. So my 3's cancel out. So what does b equal? 16/13. Okay, that's fine. So now I take my a and my b value, and I put them back into our original that we had, right? So my a value, I'm going to replace a with negative 1/13 over x plus 4. B is 16/13, so I'm going to say plus 16/13 over 3x minus 1. And then what is the proper way to write this? My 13's go where? To the denominator. So I have negative 1/13 times x plus 4 plus 16/13 times 3x minus 1. Another way I could write this is 16/13 times 3x minus 1 minus 1/13 times x plus 4. These are both the same things. Either way will work. And that, ladies and gentlemen, is the end of our review for College Algebra Trig of 2021. Yay!